Hi all, welcome back to C++ tutorial on Tute Fulcrum. This session is on C++ data types. Data type is an attribute of data which tells the compiler how the programmer intends to use the data. That is, all variables use data type during declaration to restrict the type of data to be stored. Therefore, we can say that data types are used to tell the variables the type of data it can store. Whenever a variable is defined in C++, the compiler allocates a memory for that variable based on the data type with which it is declared. Every data type requires a different amount of memory. Data types in C++ is classified to three: primitive data types, derived data types, and user-defined data types. Primitive data types are built-in or predefined data types and can be used directly by the user to declare variables. Following are the primitive data types available in C++: integer, character, boolean, floating point, double floating point, void, and void character. In this session, we will be focusing on primitive data types and will have an overview of the other two, that is derived and user-defined. The derived data types are those that is derived from the primitive or built-in data types. These can be of four types, namely function, array, pointer, and reference. User-defined data types are defined by the user itself, like defining a class in C++ or a structure. C++ provides the following user-defined data types: class, structure, union, and enum. Let's look into primitive data types in detail. To use a data type, you need to know mainly 3 points: the keyword, the memory, and the range. What range of values it can hold, what is the keyword that you're going to use to represent your data type, and how much memory is it going to store the data. Let's get started with integer. The keyword used for integer data type is int. Integers typically requires 4 bytes of memory space and ranges from the values as listed. Character data type is used for storing characters. The keyword used for character data type is char. Characters typically requires 1 byte of memory space and ranges from -128 to 127 or 0 to 255. These numeric values because the characters will be internally stored as the corresponding ASCII values of the same. The Boolean data type is used for storing Boolean or logical values. A Boolean variable can store either true or false. Keyword used for Boolean data type is bool and it takes 1 byte of memory. Floating point data type is used for storing single precision floating point values or decimal values. Keyword used for floating point data type is float, and float variables typically requires 4 bytes of memory space. Double floating point data type is used for storing double precision floating point values or decimal values. Keyword used for double floating point data type is double, and double variables typically requires 8 bytes of memory space. Void character data type is also a character data type, but this data type has size greater than normal 8-bit data type, represented by wchar_t. It's generally 2 or 4 bytes long. Void data type in C++. Void represents a valueless entity. It's mainly used along with functions. When you have to write a function which does not return a value, you make use of void data type. We can display the size of data type using an operator size of. So let's write a program and check the size of data types. So we'll check the size of int first or integer data. So suppose if you want to handle an integer data in your program, say 2, you need to have a variable for the same to hold the data. So I will use a statement like int a equal to 2. So this statement instructs your compiler that a is a variable that is capable of holding an integer entity. It is restricting a to hold only integer data. Now let's see how to make use of the size of operator to check the size of data type. So size of integer. So use the operator size of, and within parentheses you can specify the keyword for integer, that is int. So this statement will return the size of integer. So let me use an indel statement as well. So the output of this cout statement will be 4 bytes or 4. That is, typically the integer takes 4 bytes of memory. Again, the size of int can vary from machine to machine or compiler to compiler depending on 16 bits or 32 bits or 64 bits. But typically we say that the size of int is 4. Let's build and run this program and verify our output. Yes, size of integer 4. That means the integer is taking 4 bytes to store your integer data. Now I'm going to modify my program. Within this size of operator, you can also specify the variable name. So you're going to get the same output here because when I say size of A, since A is defined as an integer entity, this will return you the size of int. So you can either specify the size of int or you can go ahead by specifying the size of variable name. So you can verify this. You're getting the same output, size of integer 4. So within the size of operator, you can either specify the keyword for the data type or you can specify the variable name. So this cout statement is going to return you the size of char. So here I'm not using any variable name. I'm just specifying the keyword for the character data type. So size of char. So your expected output is 1 byte. Let's verify. Yes, size of char 1. So in a similar way, you can check the size of remaining data types as well. So let's build and run and verify our program. Yes. Size of integer 4, size of char 1, size of float 4, size of double 8, size of bool 1, size of white character is 2 bytes long. Moving on with data modifiers. As the name implies, the data type modifiers are used with built-in data types to modify the length of data that a particular data type can hold. Data type modifiers are of 4 types: long, short, signed, and unsigned. So you have short int, which takes 2 bytes of memory and ranges with the following values. Unsigned short int, which takes 2 bytes. Unsigned int, which takes 4 bytes. So when you simply say int, it is referring to signed int. So signed int is nothing which is capable of holding positive and negative values. Long int, again it takes 4 bytes of memory. Unsigned long int with 4 bytes of memory. Long double, which take 12 bytes of memory. And you have signed char, 1 byte of memory, and unsigned char that is taking 1 byte of memory. Choosing the appropriate data type can reduce the program space requirements and help improve program performance. You can improve the performance of a program by reducing the space it requires. Reducing the space requirement helps reduce page faults, segment faults, and effective address overflows. Thank you so much for watching our videos. Please do like, share, and comment. New viewers, please do subscribe and please don't forget to tap the bell icon. You will be notified whenever we upload our videos. Thank you.